Orbital Gardens, this is Mission Control. We are confirming acquisition of your signal. You are live in 5, 4, 3, 2...
Hello and welcome to episode 31 of Gardens of the Galaxy, the podcast for all of the sentient beings in the universe who have a passion for plants. I'm Emma the Space Gardener and I will be your host as we explore gardening on Earth and beyond. In episode 12 last year, we heard from Michael Wilkinson, a teacher bringing astrobotany into classrooms with Magnitude.io. Michael told us all about the Exolab-9 experiment, which would see red clover leguminauts fly to the International Space Station to investigate whether they would be able to form their symbiotic relationship with rhizobia bacteria in microgravity. Since I spoke with Michael, Exolab-9 has been to space and splashed back down to Earth with Cargo Dragon, and Magnitude.io has sent the next experiment in the series, Exolab-9, to the International Space Station. So it was a real pleasure recently to speak with Laurie Waters, Vice President at Magnitude.io, to find out how Exolab-9 went, and what's happening with Exolab-9, and even get a hint about Exolab-10. Hi Laurie, welcome to Gardeners of the Galaxy.
Hello, it's great to be with you today.
It's fantastic to have you. So you have a very exciting job because you are Vice President at Magnitude.io. So can you tell our listeners a little bit about what it is that you do?
Sure. I'm the Vice President for Learning Experiences at Magnitude.io, and we help students with experiments going to the International Space Station. And so we have an experiment, plant experiment called Exolab that we've flown a number of times. We're now on our 9th mission. And it's great because we grow these plants on the International Space Station, and then we work with students and educators around the world to grow plants here on Earth as part of the ground trials. And they have immediate access to the images and the data of what's happening with our little seedlings growing in space. So I get to help facilitate this amazing project and bring space right to students' classrooms or kitchens.
It's amazing. I wish there'd been something like this when I was at school. It would have made life so much more exciting. I mean, how fantastic is that?
I agree. And that's one of the things that's so inspiring about it, is that now we can do this with the technology and really change the course and direction for students to be actively engaged in authentic research, even when they're in elementary school, middle school, high school, or college. You don't have to wait.
And in actual fact, earlier this year, you were part of the sort of ground control experiments for Exolab-9, weren't you? You had a very exciting experience in Hawaii. So can you tell us about that?
Certainly. I was selected to be part of the High Seas Selene 4 Lunar Analog Mission, which is a analog facility. It's a simulated space mission. So we had a crew of 6 members, and we went to the top of the Mauna Loa volcano and locked ourselves into a habitat for 2 weeks. And during that simulated mission, I ran a ground trial for Exolab-9 while the experiment was on the International Space Station. So we had a true ground trial comparison of it from a simulated space mission to a real space mission. And it was a phenomenal experience because anytime we even wanted to go outside, we had to suit up into simulated spacesuits. But walking across the lava fields, you truly felt like you were on an alien planet. And then we climbed down into the lava tubes to see the extremophiles growing on the walls and on the floors and the ceiling. And you were truly transported. And that's really an area of interest as we think of future research of extremophiles being able to live in those kinds of environments, particularly on Mars, where they're secluded and protected from radiation. So we didn't see those on the surface, and then we go down below and they're everywhere, particularly photosynthetic ones. And so it was about 14 days of living like I was in that mission on the moon, and just a tremendous preparation for what we need to consider for long duration space missions to the moon or to Mars. And these analogs give us an opportunity to conduct research and really prepare and buy down the risk and have countermeasures. And so I was really thrilled to be able to be part of one.
It sounds amazing. Was it strange to sort of come back down to Earth after 2 weeks on the moon?
It was definitely strange. It took a period of acclimation, not only because of the time zone difference, but just you're back around people. So even though I had been through some isolation through the pandemic, it was still strange to go back to the grocery store for the first time and you're around people and there's noise, right? Yeah. But immediately when we stepped out of the habitat for the first time, the first thing I noticed was the wind. And I hear that often from astronauts when they come back from the International Space Station and they get out of the spacecraft, they notice the wind in the trees, and that was some of our same observations.
Yeah, they generally come back craving a salad as well. Did you?
We absolutely crave salad. So part of my research that I conducted while I was at High Seas was not only with Exolab using the red clover matched to the flight experiment, but I also grew them as microgreens. So I had the hamamaquettes where I grew them hydroponically. I grew clover, daikon radish, a salad mix, and fenugreek. And we had a lettuce grow system as well, but it was only really a few small plants. Yeah. So at the beginning of the mission, we were coming up with recipes from scratch, raw ingredients to cook, but there was no fresh food. It was pretty much dehydrated food. So by the time we get at like 10 days into the mission, the crew members are standing around my microgreens, looking at them, wanting to eat my science experiment. And so it was exciting when we got to those final days and they were ready for harvest that we could add that little bit of greenery to our soups that we were making, or we made a curry dish. But to have that taste and texture and flavor of the additional fresh food, that was really rewarding. So yes, as soon as we came back to Earth, we were looking for salads.
Okay, so I think we know that it's important that astronauts are going to be taking plants with them on their longer space missions. So it's nearly a year ago that I talked to Michael Wilkinson, your colleague Michael, and that was ahead of the Exolab-9 mission that we were just talking about there. And that's since been to space and it's come back down. And Exolab-9 is currently on the International Space Station. So what is Exolab-9?
So Exolab-9 is a replication mission of Exolab-8. We sent up 15 red clover seeds this time rather than 9. They're spread across 3 test tubes. It's the same flight hardware. We made a few upgrades and changes to it, but we wanted this replication mission to, again, try to achieve root nodulation of red clover with its symbiotic bacteria rhizobia while under the stress of space flight. And this has never been done before. So this is authentic research, and there's a lot of questions still that come up. And it's figuring out the engineering side as well as the science protocol side. When Exolab-8 returned with the Crew 1 Dragon, our little leguminauts were on board and splashed down. I went over to Kennedy Space Center and picked up our flight tubes and brought them back, and we immediately started imaging. And in that experiment, we had the media. It was like an agar, it's like an algae-based media with no nutrients in it. It had kind of rotated a little bit. And so there were some seeds in the first tube that we couldn't see very well while it was in space. And so it was really a surprise when we got them back. We could finally take a strong look at what happens in these tubes and really dig in and look down at the roots. So we found some areas of interest on that first tube. A little plant, we named them, and that one's called Dio. And he was down in the media. And so we see these anomalies on the surface of the root. And we thought we were to the point of perhaps even pre-nodulation stage. So we did some follow-up and we did some additional microscopy and some staining. And the results are still inconclusive, and especially because it was one seedling. And as we know in science, one's not enough. So we need more replicates. We need more evidence. And it's a great lesson for students as well to understand that you can't just draw a conclusion based on a single data point. So we made the decision to replicate the mission and again fly red clover with the science goal of achieving root nodulation in orbit to collect more data and evidence and hopefully see nodulation across more seedlings.
That would be awesome. As you say, that's not been done before, but that will be very important for future crops on future planets. So that's very exciting.
Absolutely, because ultimately, when we think about using lunar regolith or Martian regolith, we have to make it into a productive soil. Dead dirt doesn't grow anything here on Earth, and it certainly won't on the moon or Mars. And so being able to use that biological fertilizer to start plants growing, and then clover is used as a cover crop on Earth, right, to replenish and rejuvenate the soil. Let's plan and do that same thing on the moon and Mars.
Fantastic. For the rest of the world, when you look at Exolab-9, probably the plants that are growing on the International Space Station are the exciting part. But actually, I mean, they're just almost the sort of the tip of the iceberg, and what's really exciting is what's going on here on Earth. So you have an army of students who are helping out on Earth. What are they getting to do at the moment?
Absolutely. There are students and educators in 12 countries participating in Exolab-9. They are growing clover in their classroom exo labs, as well as individual student kits. When the pandemic hit, we decided to shift gears a little bit and create individually packaged kits for students so that teachers could get them and then very easily hand them out to students who may be in quarantine. And so there are some students who, in some countries, like in Australia, for instance, they're back on lockdown, like solid lockdown. And so they may be growing their plants at home rather than in the classroom, but it gives them an active way to still participate. And we know that plants also help tremendously with psychology, right? And being able to check and see that growth and development each day, it's comforting. I had that experience with my students when I was still teaching high school biology and AP environmental science. I sent them seeds in the mail for them to grow, tomato peppers, Jacob's Space Chili Challenge, as well as the legumes. And the families got into it, the kids got into it, and even we still find some students are growing seeds for the first time, even as high school students. And so we really are putting their seeds in their hand and planting curiosity, planting ingenuity, getting them thinking about how the different conditions they're in have the plants grow differently. And that's the other thing we're looking at is, what is the range of tolerance for these plants? Can they survive in different conditions? Can they nodulate in different conditions? So by having ground trials around the world, students are looking for those common factors that support nodulation, and then what that can mean for their local communities to plant and use sustainable agricultural methods. I love it because it gives students really that open-endedness of scientific investigation and inquiry. And that's a mindset that we need to develop in students rather than following a very prescriptive, what I would just call as a scientific demonstration, right? You already know the outcome when you start. That's not what we're doing here. We want them to experiment with, even we're looking at some soils investigations as a follow-up to this mission and having students grow clover in their different soils. Wouldn't that be amazing to compare the color, the growth, the time to nodulation, and look at how those soils can make a difference, right? And so it is an open-ended scientific investigation, and that is just such a crucial skill for them to learn at a young age, because when they get into the world of science and engineering beyond their college careers, it's not all going to be predetermined. They have to be able to think, right? And so think outside that box, and that's what we're doing with them.
Brilliant. Okay, so I mean, Exolab is coming back home on Cargo Dragon later this month. That's the plan anyway. So, I mean, you mentioned a little bit about soils, samples and things like that. What is next for Exolab once Exolab-9 comes back to Earth?
So we'll bring it back and we'll do post-flight science with microscopy. We're looking at engaging some undergraduate students at a university to assist with that post-flight science as part of their research even, and look for signs of nodulation. And then the next step is we do have Exolab-10 scheduled for October of 2022.
Wow.
And so mark your calendars, and for students and educators of all ages, they can start getting engaged with us this year as we start asking the questions, what is next? We haven't decided what we're sending up yet. We have some leads based on some great suggestions from Dr. Joy Amasa, the Kennedy Space Center plant scientist. She was with us last week during one of our mission calls, and she gave some great ideas about testing different technologies. Yeah. So I envision, especially with this Exolab 10 mission, that we may break out of these 3 test tubes and have a different type of box. Maybe we go with the magenta box, or we use a different form factor that fits in our 4U cube lab.
Yeah.
And do we monitor a different way? What are the lighting conditions? One of our challenges on Exolab-9 has been our grow lights have not functioned properly. And so we have to use a different set of LED lights that were initially only going to be taking a picture or lit up just to take a picture once an hour.
Okay.
But now they're on the whole time, and it's a percentage, like about 26% of what we were originally going to have. But we figured out that by doing the math, it's the equivalent of growing clover on Mars in a greenhouse in a dust storm during the winter. So, we kind of got thrown a little bit, but we problem solved through it with the engineers and said, this is what we can do. And so I think we have to present to kids both engineering challenges as well as the science challenges, because some kids have strengths in different areas. And so I think there's still an open door for students to suggest and recommend, where do we go next? And Exolab 8 started with a leguminaut challenge. Which plant should we fly? Which legume should we send up?
Yeah.
And red clover was chosen. And so now for Exolab 10, it's what should be our science question. It will be a plant experiment. And I want to try to continuing to build off the concept of legumes and root nodulation. But there's still so much to be researched and considered. So join us for Exolab 10 and start with us with ground trials very soon.
Fantastic. We'll keep an eye out for that. Okay, so you've said your mission is to cultivate the next generation of scientists, engineers and leaders by igniting curiosity and ingenuity, which I think is the best mission statement ever, actually.
Well, thank you. It's pretty exciting.
And as an analog astronaut yourself, which is also amazing, how do you feel about the success of Inspiration 4, the first sort of civilian space mission, which has just been to space and splashed back down?
Space is for everyone. And I was able to see it from my backyard here in Florida, the little blip of the rocket going up before it got into the clouds. But it is truly inspiring, and especially to see their connected mission to raise money for St. Jude's. Yeah. And we have a good friend whose daughter gets treatment at St. Jude's, and so it's very personal as well. I did try to get on the Inspiration 4 mission for the generosity seat by making that donation to St. Jude's. So it is inspiring to see the stories and the backgrounds of these individuals who then did substantial training over the last several months. They brought their skills and strengths and enthusiasm, passion for space, and they went up there for 3 days and orbited. And then they conducted science while they were there. It was not just a joyride. It was a meaningful experience to show every child around the world, no matter where you live, no matter your background, abilities, you can be a space person. You can be an astronaut and go to space. And it's opened up. It really has. With every one of these, from suborbital, Virgin Galactic, and Jeff Bezos with Blue Origin, and now with Inspiration 4, space is for everyone. And it is truly inspiring. And to see what Haley Arsenault went through as a child in recovering from cancer and then having a prosthetic and having some disability, with that, I think that's truly inspiring too, that while you may not be quote unquote, what would have been Apollo perfect, right? That's no longer what they're looking for. They're looking for people who are skilled and passionate and the positive growth mindset, and teamwork, how much they emphasize collaboration. And that's something that really, from my analog mission, it took all 6 of us working together, and we would offer to help each other with the research. We all took turns with cooking and cleaning and maintaining the habitat, supporting each other out on EVAs. Crew would go out and 2 people would stay back to run the communications and be there for a safety net. So it's more than just being a test pilot from the military. It is now, if you have the passion to do it, you can achieve it. And so I think it is truly a new day as we see commercial space stations in the beginnings of development, and as we're headed back to the moon and ultimately to Mars.
Okay, so you mentioned the moon and Mars there. So if you were able to join a community on the moon or on Mars, or if you prefer on Venus, I'm not fussy, you're on a deep space mission and you can take one plant with you. What plant do you choose and why?
Well, I'm going to assume, like you did recently, that they are growing food as part of this colony because the settlement, because we do know that fresh food will be crucial for long duration space missions. So there'll be the microgreens, there'll be the salads, there'll be some fresh food. So that's taken care of. So the one that I would take is the Christmas cactus. Because, first of all, it's one of the first plants that I grew. And when I was in high school, my mom gave me a cutting of hers that I took to college. And so that was really my first plant. And I was able to fit it in my dorm room. It was small, but then it grew, and then I could clip off the cuttings and give them to friends. And so I would not only enjoy this wonderful, beautiful plant throughout the year, and then as it flowers, it's gorgeous, but then also be able to share my plant with others by giving people cuttings. And so it's a great memory back to my childhood and early career. And then I think it would be a great addition. And it's easy to keep alive. So we can't have them dying off on us because we're far away in deep space, maybe on Mars or even Titan.
That's brilliant. I think that's got everything because, as you say, it's a beautiful plant. It's got sort of seasonal interest. You've got that sort of nostalgic link to your past, which I think would be important on a deep space mission. So that's really brilliant. But I also love this idea, this sort of gardening spirit that we're launching into the cosmos, that I'm going to take this because then I can share it. It's going to grow and I can take a cutting, or I can, it'll seed and I can hand it out. So everybody takes something different and everybody's going to have a massive garden in their quarters by the end of it because they're going to have one of everything. She's going to take over the entire,
They will all want plants.
Even the people who didn't come with plants will be like, hello, welcome to the colony. Would you like a plant? Here's your welcome plant.
Exactly. I think we should have welcome plants.
How good a gardener are you? I've read your file. Here's a spider plant.
Exactly.
Here's a cactus. Be careful with that one. Okay, so that is absolutely brilliant. I'm looking forward to seeing what you find with Exolab-9, and also what you come up with, what you and your students come up with for Exolab-10. So that's very exciting to look forward to next year. So that's brilliant. Thank you so much for coming on the show and sharing that with us. It's been wonderful to have an update on your work. So that's great. Thank you.
Thank you so much. We appreciate you so much for investing in this show and sharing all these different speakers over this last year who've got expertise in growing plants and sharing that with us. And so I'm a huge fan of your show, and I promote it to students of all ages as well, because it's got so much history, and then you just start thinking about the potential of what's possible of growing plants. And we will not survive in the universe if we don't take some organisms with us, and plants are going to be essential.
They are. Absolutely. Well said. So thank you very much, Laurie. And as I say, we'll be keeping an eye on what goes on with Magnitude.io and the Exolab experiments, and I'm sure we will come back to it in the future.
Great. Stay curious, everyone.
Thank you. Goodbye.
Bye.
I spoke with Laurie in September when Exolab-9 was still orbiting the Earth on the International Space Station. By the time you hear this, the latest batch of intrepid leguminauts should have splashed back down and made their way to the lab for the next phase of their mission. I'm Emma the Space Gardener, and you're listening to Gardeners of the Galaxy. I love producing this show, the Gardeners of the Galaxy newsletter and my Meals on Mars newsletter, but it's a lot of work, and to keep things going, I need your support. I'm so grateful to the small band of fans who have joined me via Patreon. If you are able to make a regular financial contribution, however small, then sign up via patreon.com/Gardeners of the Galaxy for bonus content and early access to episodes. Or you can make a one-off donation via ko-fi.com/Orbital Gardens. Together we can push Gardeners of the Galaxy into higher orbits. That's it for this episode. I'll be back in a couple of weeks with episode 32. Thanks for listening. Goodbye.
Orbital Gardens, this is Mission Control. We are confirming termination of your signal. Unfortunately, we have also lost your movie requests, so we have picked you The Martian and Frozen. Uplink commencing now. Mission Control out.